Hi friends, in this video we are going to see how to use KEDA or how to enable KEDA, which stands for Kubernetes-based event-driven auto-scaling on a Kubernetes cluster. I've been using KEDA for most of my public talks for quite a while, and I've also been using Azure Kubernetes Service, which is the managed offering from Microsoft Azure for the Kubernetes. So let's get started and see what do we need to have KEDA enabled on our Kubernetes cluster. Let's first understand what is KEDA. KEDA is a single purpose lightweight component which can be added to any Kubernetes cluster. It allows us to have this scaling using the horizontal pod autoscaler, but based on the events or based on the triggers which are outside of the Kubernetes cluster. And I've been using KEDA for quite a while. I've created multiple videos on this particular channel, and if you go into the playlist, you will find a playlist related to KEDA which I did almost 4 years back or 3 years back. This talks about how to use KEDA, how to scale your containers or how to scale the applications using KEDA, and how to provision a Kubernetes cluster. This was long before, and there are things which have changed over the years. So let's get started and see what change is required nowadays if we have to enable KEDA on our AKS or Azure Kubernetes Service cluster. So first of all, we can go over to the KEDA website, keda.sh, to find out what is KEDA and what does it has to offer. One of the things which KEDA does very well is to provide a set of scalers, out of the box capabilities to scale our applications or deployments based on various metrics. This can be things like ActiveMQ, that can be Apache Kafka. We can have things like CouchDB, Cassandra. This can be based on CPU. It can be a SaaS product like Datadog. Elasticsearch can be used, so on and so forth. The list is quite huge. We can go through this list and find out which is the out-of-the-box supported scaler. Once we have decided which scaler has to be used, we can then enable it using a type of object called as a scaled object, and we can target a deployment with that. But that's not the purpose of this video. We are going to see how to enable KEDA on Azure Kubernetes Service cluster, which enables us to have KEDA as an add-on, which means that the upgrades to the KEDA and its related services is done automatically for us. The easiest way I found out to enable KEDA for our Kubernetes cluster is to enable it during the cluster creation itself. And over the period of time, I've built this script which enables me to create a AKS cluster. So here the script takes series of options, or it takes various defaults, starting with the subscription name, which is Microsoft Azure sponsorship. You can change this to match to your Azure subscription if you want to use this same script again with your own parameters or with your own Azure subscription. Then we have the resource group name, which needs to be created. We name this as Demo Azure Singapore RG. RG is the acronym for resource group, which I use for easily identifying that the type of resource is a resource group. And then we have the location of this resource, which is Southeast Asia, which is the Singapore data center. And then there are cluster specific things or Azure Kubernetes Service specific things like the cluster name. In this case, we are naming this as Azure Singapore cluster by default. If we want, we can override this when we execute the script. Usually I just run the script with defaults. Then we have the worker node count as 3. We also have the Azure Kubernetes version 1.26.3, and then since I use a private Azure container registry, I've given the name of the ACR registry here. We start by setting the subscription using the Azure CLI or AZ command line, and we set it to whatever is the subscription name we specified above. Then we do a quick check. The script is idempotent, which means that it can be run multiple times, and if the resource doesn't exist, it will go ahead and create. If the resource exists, it will skip that particular step. So in this case, we are creating the resource group. We first check if the resource group exists. If it does not, then we go ahead and create that particular resource group in the location or in the data center that we have specified. And Then we try to check if we have a particular cluster with this particular name, whatever name we are trying to create the cluster. If again the cluster doesn't exist, then we will run this command, which is AKS create, and it passes all those parameters that we specified at the beginning of the script. We are enabling some things like the managed identity, which is used to assign automatically created identity, and this identity is managed by Azure for us. And then we have this flag called attach ACR to attach the Azure Container Registry to this particular cluster. And the last line, line number 54 in this particular script, says enable-keda. So that is the easiest way I have found to create a Kubernetes cluster and enable keda for that. So let's go ahead and run this script and see how it goes ahead. So to run the script, I'm going to use the terminal, and I need the Azure CLI installed to run this script. So I have this AZ version command to look at what's the current version of the AZ CLI that I have. Now we can go to the projects, and under the Cloud Native Ninja, I have the scripts folder or PowerShell folder where this particular script resides. It's called as initialize AKS. This is the script that we are going to execute. Before that, we can run a command to find out AZ AKS and what are the versions available. So let's start by first looking at what are the versions of Azure Kubernetes Service that are available for me in my location, which is Southeast Asia, which I can use to create a cluster. This I can do by running this command called AKS list, and let's output this as a table by using /output and table as the parameter. So here we see that the latest version is 1.28.3 or 1.28.3, which is available, and there are previous versions going back all the way to 1.25.11, which I can use to create a new Kubernetes cluster. Now, if I go back to the script, the default value right now is 1.26.3, and we see that 1.26.3 is currently not supported. So I'm going to use the latest version, which is 1.28.3. In this case, let's use the most recent version which is available, and then let's go and run that PowerShell command. Let's start by running this PowerShell script, which is named as the initialize AKS, which will run all those commands that we saw in the PowerShell. So here we can see that it has tried to set the Azure subscription to Microsoft Azure sponsorship, which is my subscription that I specified in the default parameters. Then it has created a resource group called as demo Azure Singapore RG, and then it's trying to look for a resource in this demo Azure Singapore RG with the name as Azure Singapore cluster, and it's not found. Since it is not found, it is going to create the AKS cluster, and this is where we enabled that setting saying enable the add-on as keda. So if we go back to our script, we see this enable keda as the flag which is specified while creating the AKS cluster. Now creation of this cluster will take some time, so I will pause the video here, and once the cluster is created, I will come back and we will resume from there. So here we can see that the Azure Kubernetes Service or AKS cluster has been created as a result of that command running, which is AKS create, and we can see here that the orchestrator version or the kube version is 1.28.3, AKS version is 1.28.3, and it has all the other properties which are default or the ones that we specified. If we scroll down to the bottom, here we can see that in terms of the scalar profile, there is this keda is enabled and it's set as true, which means that the cluster has been created with keda enabled. The way we can verify this is we can use again a CLI command, which is to use, or which is used to verify whether the AKS cluster has been created with KEDA or not. So we will use this kubectl get pods, and then we identify the pods which are part of the kube system namespace. Here we can see that KEDA admission webhooks, then KEDA operator. These are the pods which are created, which are related to KEDA. And it also creates a custom resource definition, which we can query using this getCRD scaled object, and we can verify that it has the KEDA related settings. So this is the output of the getCRD command, and we are outputting it in YAML format. You can see the type is custom resource definition, and it is created using Helm. So internally, when we say enable-keda, AKS, when it is provisioned, it is using Helm as the operator, or it is KEDA operator is deployed using Helm. And we can see the version of KEDA, which is 2.11.1. Now this version depends on the version of the AKS cluster that we are creating, or the Kubernetes version that we are using. So you can find the list of supported AKS add-ons using this particular link. I will put this link in the description. So if we are using 1.25 version, we can see that the KEDA version 2.9.3 will be installed. If we are on 1.26 version of Kubernetes, it will be 2.9.3. 1.27 would have 2.10.0 version, and since we are on 1.28 version, KEDA 2.11.2 is installed or enabled when we say that enable KEDA. So the version of KEDA is linked to the version of Kubernetes that we are creating the cluster with. Now with that, we have enabled KEDA, and we can also see this using Lens IDE, which is one of my favorite IDE for visualizing the state of the cluster. If I look at the configurations, and if we go under the horizontal pod, autoscalers, or HPA, and we look at the kube system in here, and then go and look at the horizontal pod autoscaler, currently there is nothing under the kube system. If we go under the custom resource definitions, we can see here that scaled object and scaled job. These are the two custom resources which are created for scaling the jobs and the objects. There is also trigger authentication and cluster trigger authentication. These are the four custom resources or CRDs created by KEDA, or created for having the KEDA related resources in our cluster. There is also keda.sh which have these object definitions. So if we look at all these things, when we see them, that means that KEDA has been enabled for our cluster, and we can then automatically scale our applications based on certain events or triggers which are outside of the Kubernetes cluster. If you would like to understand about that, I recommend that you go through these earlier videos that I've done. And on my YouTube channel, under the playlist, if you look at the virtual community events, I've also given multiple talks where I talk about KEDA and how to use KEDA for different types of scaling. I hope you found this useful. This is the easiest way I can see at this moment to enable KEDA for Azure Kubernetes Service. In case you found this video useful, please hit the like button, subscribe to my channel, and share it with your friends. Thanks for watching. Until next time, code with passion and strive for excellence.